What's so remarkable about the Egyptian system is that they were one of the first to standardise length measurement. It's said that every full moon, the surveyors across the land would gather and compare their wooden cubit rod against the royal master cubit. Made of granite, this was held by the royal surveyor. Failure to maintain an accurate cubit was punishable by death. It was a very simple and efficient way to standardise length measurement across the land, and it enabled the Egyptians to measure things with phenomenal accuracy. Mastering and standardising time and length measurement was really key to the success of the ancient Egyptian empire. The power of measurement is that it created order out of chaos and allowed civilization to flourish. The standardisation of measurement, which began here in Egypt several millennia ago, is now central to all our lives. Nearly every country in the world has a national measurement body whose master lengths and weights are calibrated by one international body. A little bit like the modern-day pharaohs trying to bring standardisation of measurement across the globe. But despite the obvious logic of having one international system, it hasn't been completely embraced. Take me, for example. I'm going to the airport in this cab, which measures its speed in kilometres per hour and miles per hour. When I'm up in the air, they'll be measuring their altitude in feet. My clothes are measured in inches, and my shoes are measured in, well, frankly, I've never quite understood what the unit of measurement for shoe size is.
Shoe sizes aside, standardisation of measurement underpins all modern science, though the road to standardisation has not been an easy one.
Throughout history, rulers had a nasty habit of ripping up measurement systems and demanding that they be replaced by lengths based on their own body parts. In 12th century England, the yard was defined as the length from the tip of the king's nose to the top of his outstretched thumb. But as each new reign came in, so things changed. Henry VII, he defined a yard as the length of his arm. Elizabeth I, well, not to be outdone by her male predecessors, added a few more inches. And so the chaos continued.
Lack of standardisation was a problem on the continent too.
If you thought the British had it bad, then spare a thought for the French. On the eve of the French Revolution, the Ancien Regime had over 250,000 different weights and measures, including several thousand for length. By the end of the 18th century, people realised that something needed to be done. Trade was impossible and open to fraud, navigation was treacherous, and building plans made by an architect in one city couldn't be reproduced in the other because they didn't have the same measurements. The mess was finally sorted out by the French Academy of Sciences. It was the last few days of the French monarchy, and buoyed by the revolutionary spirit of the time, sense of equality and rationalism, France's best scientists decided to form a groundbreaking revolutionary plan of their own. No longer would measurement be based on the human body or the vanity of kings and queens. They decided that it should be based on something permanent and unchanging. They chose the Earth.
It's really exciting to be here. This is really one of the great scientific centres in the whole of the world.
And this is where the modern story of measurement really began, where a new standardised unit of length was introduced, one that is familiar to us all today.
On the 26th of March 1791, the Academy here decided to call this new length measurement the meter. Named after the Greek word metron, meaning measure, they decided that it should be 1/10,000,000th of the distance between the North Pole and the equator.
It was very clever. The Academy knew that a French colloquial measure would never be accepted by the rest of the world. By basing the meter on the planet itself, no one country could argue for their own measure. They had transcended the politics of nations.
This is a system for all people for all time, announced the revolutionary government. There was one problem, though. Nobody knew accurately what the distance between the North Pole and the equator actually was.
Getting an accurate figure would mean embarking on the most ambitious and complex large-scale measurement project ever attempted. Two scientists were tasked with turning the theory into reality. They were Pierre Méchain and Jean-Baptiste Delambre. Their task was to measure the distance between 2 points on a meridian or line of longitude. Then, using fairly simple mathematics and knowing the latitude of each point, they could extrapolate and calculate the distance from the pole to the equator. This experiment would be difficult enough under normal conditions, but France was in the middle of a revolution. It was a dangerous time to have big ideas that were not necessarily easy for the new order to understand. Nevertheless, undaunted, the scientists pushed ahead. It was here in 1793, from this bell tower in Dunkirk, that Jean-Baptiste Delambre started the northernmost part of his epic quest to measure the Earth. While 800 miles to the south, Barcelona was chosen for Pierre Méchain. Their plan was to work towards each other and meet in Rodez in southern France.
You can imagine Delambre's excitement as he stood up here 200 years ago, ready to start his journey. A journey that would take him 7 years to complete.
And the rather splendid piece of equipment they used was this: a repeating circle. A device that measures angles extremely accurately and as good today as the day it was made.
Now obviously Delambre wouldn't measure every distance from here to Barcelona, but what he can do is use a method called triangulation. So the first point of the triangle is the top of this belfry. Then Delambre would have looked across the countryside trying to find two high points, and he would use this piece of equipment to line up the telescopes on those two other points.
Then all he had to do was measure the angle between the 2 points and measure the distance to the closest one. By then moving to the next high point and measuring the angles again, simple geometry gave him the distances between all three.
So it's an amazing principle, because just one measurement of distance and then there's triangles all the way to Barcelona.
Delambre had a number of close scrapes along the way. He was arrested several times, accused of being a spy. Why else would he be scaling towers, carrying strange equipment? He tried to explain that he was measuring the size of the Earth for the Academy of Sciences. But a drunk militiaman interrupted. "There is no more academy. We're all equal now. You'll come with us." But in general, they were literally above it all. On rooftops, towers and church spires, they carried out their quest. It was an extraordinary feat. 7 long years later, the two men had measured the exact distance between Dunkirk and Barcelona. Now the meter was just a simple calculation. The result of all Mechin and Delambre's hard labour, the prototype meter bar, is held here at the French National Archives in Paris.
Made in 1799 of pure platinum, it's meant to represent 1/10,000,000th of the distance between the North Pole and the equator. In fact, due to errors that Mechin made early on in his survey, it's fractionally wrong.
The errors that Mechin made were pretty much irrelevant, because for the first time, the world had a unit of length that was based on something they believed was permanent and unchanging: the Earth.
There it is, the meter. A thing of beauty. Not so much the objects, but the idea it represents. This meter bar ushered in the era of metrification. The achievement is immense. Even Napoleon, in a moment of humility, admitted that conquests come and go, but this work will endure. And he was right. This lump of metal really represents a change in our thinking. For the first time, we had measurement based on something fundamental and universal.